Hello and welcome. So another Marshall. This one is a Marshall Class 5. And if we have a bit of a look, if I just tip that over so we could look in at the controls, might get a bit of camera flicker with this very bright fascia panel. So this is a very simple design. It's a single-ended 5-watt amplifier, volume, treble, middle and bass, and that's it. That's all it's got on it. PC board extravaganza. What is this amp in for? Well, it's not in because it's broken. We're going to mod this amp. This amp belongs to Lee at the shop, and we're going to do some mods on it. So what we're going to do is we're going to have a listen to this amp first, and then we're going to mod it and have a listen to it and see if I make it sound better or worse. But yeah, let's have a look at the back anyway. So we're looking at the back now. There's not much to see really. We've just got a headphone socket, which is handy, and a 16 ohm extension speaker there. So I'd imagine that cuts out the speaker on this if that's 16 ohms, because normally when you plug into a socket it wires parallel. So if that wires to 16, that means that's 32, and that's no way. So I'm guessing that cuts out if I'm correct. And we've got this select switch here, interesting as well. So yeah, it's model C5 this one is. Right, what we need to do now with this amp, we need to plug it in. Right, we've got this amp plugged in, and I have to be honest, I've never played through one of these before, so let's have a bit of a play. First impressions of that to me is a little bit nasally, as I always say, which is how I am at the moment with this cold. Boxy, that's with the middle out, completely out. Let's try it with boxy and a bit woolly as well. We need to see if we can brighten this amp up. It's plenty loud enough. We just need to see if we can brighten it up a bit, make it sound a bit more three-pulsious. Don't look that word up in the dictionary, it's not there. Well, I don't think it is anyway. Right, we've got this out on the bench, this Class 5. We're having a look. So we've got the output transformer, which will probably be an EL84. We've got a Marshall ECC83 with the date code of 09. So that probably is the original tube, because on this transformer we've got a date of 09. And then that one looks like one of those Yugoslavian tubes to me. EIs, I think, or ELs, I can't remember now. Yes, output transformer. My dog's nuts are bigger than that. And now we'll have a look inside the PC board extravaganza. We just need to prop something up. Sorry, we just need to put something underneath to prop it up, should I say. In fact, we need to put something on the other side as well to prop it up. So a couple of these boxes that we've got there, let's just move back. That feels a little bulgy on the top. So that's another thing with this amplifier as well. It's an 09. So that's what, 14 years old, this amp? I've got another date, yeah, 2009, we can see that. So this, as well as this amp, you know, modding this amp, we've got to consider about a recap on this amp as well. That I don't like the look of. So I think the first thing I'm going to do on this amp, before I do anything else, is I'm going to take some readings and measurements to find out what's actually going on with this amp. So we've got some idea of what we're dealing with. So that'll be the bias, and obviously that'll include the plate voltage and so on. What drop-in resistor we've got for the bias, any resistors that are not in tolerance, or should I say are not up to the job. So let's get it plugged in and do a few tests on it. Right, so the first thing I want to check on this amp is the filament voltages that we've got on here. So that will be pins 4 and 5. 1, 2, 3, 3, 4 and 5. 6.53. So that's okay. So this amp is set for 240 volts. That was one thing that I was pondering on after the fenders that were imported into this country are all at 230. That is at 240. So that's good. So what we're looking for now, see what plate voltage we've got on there. Pin 7, 275, and let's have, that's plate cathode we're really interested in though. 267 plate cathode on there, 8.17 volts on there. So we're going to switch off. So let's see what resistance, what impedance we've got on this. 147.5 that measures. So let's do a bit of maths on that then. With the calculator, the sports brand covered over, other sports brands of calculators are available. I bought this so I'd never lose it, and 2 days later I'd lost it. So 8.17 divided by 147.5 is 55 milliamps, 55.3 milliamps. Take away 5% for the screens, that leaves 52.6 milliamps, and we times that by 267, and that tube is dissipating 14 watts, as you can see there, according to my mathematics. So that is a little high. Transformer, really warm. It's not very warm in here at the moment, but yeah, when that's drawing a little bit too much current for my liking. So we may look at the bias as well on this amp. It's a little bit high. It doesn't really need to be 14 watts, does it? So that's what's on the screens. Let's have a look. What's on the screen? So screen is pin 9, screen to cathode. Oh, switch the meter on. It always works better when it's switched on. 259 volts, so there's no issues there with the screens being higher than the plates or anything like that. Always check for these things. So that's basically where we are with this. As I thought, that transformer's coming out at 5k primary according to the, well, that's according to the volts that we've got there, and the dissipation. Chinese, then that must be. Let's have a look at that. You can see there, there's a bit of an E there, white E on there. Don't know what that's about. And if anybody knows, if that's of any significance, somebody let me know in the comments. Of course, this writing on here that was in red ink, and you can just see a little bit of the red ink there still, and it's turned gold because it's running so hot, because it shouldn't be running at that temperature. Actually, I might try with those voltages. I could try some of the Russian tubes in here that I've got, because that's not a particularly great tube, is it really? I suppose they're all right. Anybody know anything about these Bulgara tubes? Anybody? I don't think they're very good. I think the Chinese tell me different in the comments if you know something about those. I don't know very much really, do I? I don't tend to read, you know, a lot of stuff that, you know, gumps and things, and I only tend to, you know, and I have come across these tubes before, but it's only when I start to analyse things. I don't do a lot of reading on tubes and things. I tend to do a lot of reading on amp design and well, I do actually do reading on tubes, but not regular tubes. It's usually, I'm into, you know, television tubes and things that I think I can recycle and reuse. Is that's the thing with me. I just can't stand to see all these old mullards just being thrown away, you know, going to the landfill if we can make use of them. We have a visitor. I'm afraid that she's going to have to vacate the premises, because while we're messing around with the electric, I'm afraid Pink isn't allowed on the bench. But everything is switched off at the moment. Yes, and it's the give me some food look that she's got there. So I think I'm going to have to feed her to get rid of her. Right, we've got this board out so we can look at it in a bit more detail. Oh, look at that. Oh, I'm afraid we've got double dye joints there, madam. Dry joints on there, if you can see that. On there, but there, so we need to solder that up. Yes, so there's a few things we need to address on this amp. This amp is Lee's own amp, so this is why we're going to town on this really, and I just thought it would make a good video. Very easy to work on this board once it's out, but we do need to go across it, and of course the other thing when you're doing these is these will have non-lead solder on them, and you can see there's dry joints in a few places on the bigger components, so we need to suck all this solder off because it doesn't sit well with the lead solder. Sockets look okay at a glance, but again we'll inspect those with a bit more severity. Now the other thing this amp's got is 100 microfarad first node capacitor, and I would have thought 47 would be plenty for that. 100 seems a lot to me for a, you know, for a single-ended 5-watt amplifier, given the fact that Defender Champ only has 8 microfarad, sorry, 16 microfarad, has 16 microfarad, which leaves them a little bit hummy, but 47 should be ample really. So I think I might change that because it's a bit bulgy on the top, and it's also 14 years old, and I think I've got a 47 radial, if we can get it to fit in there, at 450 volts. It's smaller, but it'll be a new one, and I don't think we really need 100 microfarad in there. So I might look at changing that. And then we've got 47 at 500 volts, so I don't know then, is that the first node or not? I'll have to check this schematic in a bit more detail and look at that. So we're definitely going to change him because he does look a bit iffy. And then we've got a 47 at 500, which I don't really know why we've got a 47 at 500, given the fact that there's nowhere near 500 volts on this transformer. If we check from pin 9 to this resistor, yeah, we've got continuity. So that is we've got this drop-in resistor here, this one that's loose, and then we've got a 1k here, so they must be, this 1k is really a screen resistor, so that's okay. Obviously this is another drop-in resistor, which I pointed these out. So if we run through here, you can see we've got this 1 watt, and then that one looks a bit less than 1 watt, but it probably is 1 watt, it's probably just my eyes, and that's running down here, and that'll probably be, will be going to this pin here, and that will be 9876, yeah, because that's a plate, so that's good. So we know pretty much what these resistors are doing now on there. We can see, just hone in. So we've got 220 ohms at 5 watts. We've got 1k screen resistor. That would be better if it were metal oxide, but it's okay. And we've got a 10k. In fact, that's what I'd call a 1 watt resistor. That to me is like a half watt or a 0.6 watts. They've got to go, haven't they? They're too small for this amp. I don't want those in there. So I'm going to swap that. 10k, we'll see what way. I think that's 10k anyway. Yes, it is 10k. And then we've got, that one is also 10k. Yep, it is. Very good. So we'll swap those while we're in here. So I've just been looking at these caps on this board. We've got 100 microfarad at 450 volts working. Node 2, we've got 47 microfarad at 500 volts working, which is odd. Now I have got, as we're going to remember, we're going to replace this for a 47. I have got 47 microfarad at 400, and I need to check that 400 is going to be enough. So what I've done is I've measured the AC coming out of the transformer. At 240 volts we have 250 volts AC. So to get our calculation for that, if we times that by 1.414, that's 353 volts. So we're well inside it with a 400 volt cap there. Not sure why we'd have a 500 on the second node and a 400 there, but we're seeing well inside with that. So we're safe to use a 400 volt cap on there, and that's really, if you can measure the AC off the transformer, times it by 1.414, you can then find out what, and that will be the voltage that hits these caps when this amp is first switched on. Remember, that drew down to 267 plate cathode, so that's only when it first hits the caps. What you don't want to be doing is if that was like 420 volts when it hit the caps that I'm putting in, there's only 400 volts there, so 400 volts working, so you'd be 20 volts over every time it was switched on. So we're 50 volts under near enough, so we shouldn't have a problem putting a 400 volt in there. Right, we've done most of the mods on this amp. It's just the bias that's left to do. We've swapped and wrapped, and we've got it how we like it. So what have we changed in here? We have an 820R resistor on the first stage, and we have 660 nanofarad. This is plexi that Lee wanted this done to sound, well, as much more towards the sound of a plexi. We're never going to get this to sound like plexi because it's a single-ended amp, but more along those lines. So we've got on a plexi, you've got 680 nanofarad bypass cap on the first stage. I'd got a 680, but it wouldn't fit in the little hole. In fact, it was massive. So what I've done is got two 330s in parallel, and I've put one in the original hole, and I've put the other one across the resistor, J-hooked it across. It's not ideal, but it's the only way I could do that really to get it right. So that's done. That 220 has been changed, took out, but it's the same one that's gone back. The tone stack is a plexi tone stack now. What else? 470k has been changed to 1 meg. I need to snip that off actually. I've only cut one side off of that. That's 1 meg. We need to get rid of that. And then I've recapped this amp as well. I've changed, I've removed the 100 nanofarad cap that was in there, that was already decoupled after the tone stack, and there were a couple of 2.2 nanofarads. I've made those 10 nanofarad, just up those a bit, and I changed the other plate resistor, one of the other plate resistors to 100k. The others were already 100k. Now I've also changed some of the power supply on this. So it had a 100 microfarad cap on the first node. That's just way too much for this amp. It just makes the bottom end really stiff, and so it's not a PA, it's a guitar amp. So I've dropped that to 47. Remember, in a Fender Champ you'd only have 16 microfarads there, so we've got 47, 47, that was 22, so they're both 47s, and then instead of the 10s we've got 22s. So we've upgraded some of the smoothing on the preamp stages. We've just reduced it slightly on the first stage, and we've upped it slightly on the second stage. And the other thing I've changed on the power supply, other things, this resistor here, there was a 5-watt one. It was getting a bit hot. It was also stood up rather high. It's this one, and it was getting towards that jack socket. It was getting a bit hot. Wasn't an ideal place, so what I've done is I've put that one in. It's also close to this capacitor as well, so I've actually now put a 10-watt in, and I've tipped it back, moved it away, and it's lifted off the board. Now and then the 10k resistors are now 6.8k resistors, and they're 2 watts, as the others were supposed to be 2 watts, but they weren't. They were 1 watt. They were nowhere near as big as these. So these are 2-watt metal films. Metal oxide, sorry, not metal film, metal oxide. I've put some bright caps over some of the it's got some 470k grid stoppers and things, so I've put some 470 picofarad bright caps over those because it was a bit muddy with those, and that's what they do in the JCM 800. So we've took quite a lot of ideas from Marshall amps on this one. What else? Now then, the tube that was in it was that Chinese Bagheera tube, which was biased at 14 watts, which obviously was too much for this amplifier. So what I have put in this amplifier is one of the Russian tubes that I've been using. I've been doing some experiments with a lot of these Russian small pentode, 9-pin pentode tubes. This amp has got in 6P4 3P it's 12 watt dissipation. So 6P43P has gone in here. Why am I using some of these Russian tubes? Well, they're good tubes. I've been doing a lot of experimenting with them. They're good tubes and they're cheap. They're relatively cheap. So this amp's not got a lot of HT voltage on it, so the tube's well within its specs. It's the same pin out as an EL84, so you could put an EL84 back in this. These tubes do draw more current, and that's what we'll get onto in a minute, the bias. Now, the bias resistor in here was about 3 watts and it was 150 ohms, and that Bagheera tube obviously somebody shoved in this amplifier. And this thing that people say, oh, cathode biased amps, you can put any tubes in, they don't need biasing, that is not true at all. This amp wasn't biased at 14 watts from the factory. Somebody's put that Bagheera tube in there. These Russian tubes draw more current. If you this amp was biased at 14 watts with that Bagheera tube in. If you put one of those Russian 6P43Ps in, you'll get 18 watts. There's 4 watts difference. So you have to then alter the drop-in resistor across the bias. So we have now got a 612 ohm resistor in here instead of 150 ohms. So let's just have a bit of a look at this bias situation then, and just see where we are with the bias. So if we go and I've got that bias resistor jumpered in at the moment. So I've got 28 volts across that resistor, and obviously it's actually a 620 ohms, but it's actually 612. Divide by 612, you've got 45 milliamps. Take away 5% for the screens, leaves 43 milliamps. And if we go plate to cathode, we've got 252 volts, and that's 10.9 watts, 11 watts there, and that's fine for this amp. 11 watts is fine. We don't need to push it too hard. Transformer's lukewarm, as it's been running quite a considerable time, so that's fine. So what I'm going to do now is I'm going to take this board out, solder this 612 resistor in there, 620 but it's 612, and then we are going to get this amplifier on the 4x12 and have a bit of a listen. Right, we've got this class 5 on the 4x12. We've not got it buttoned up yet, so we're going to have a bit of a listen. So this guitar's in single coil mode at the moment. moment. Let's try it on humbucker. So this is a Marshall plexi tone stack, but instead of putting a 470 Pico in, I've put a 250 Pico just to give this amp a bit more scope. That's worked really well. Mid control works well. So there we have it, the class 41, the 4x12. So what we're going to do now, I've just got a bit of glue to put around these capacitors because I thought I'd run it up first in case they had a bad one. As you do get new caps that are bad occasionally, so I'm going to just put some glue around these caps and then we'll put it in its case when it's buttoned it up in its case, and then we'll try it on its own speaker. Right, it's buttoned up back in its case on its own speaker. Speaker does lack a bit of bottom end, so probably I can't remember which model that was now, I didn't really look in there. Well, you could probably do a bit better speaker in, but then that could be said of most amplifiers really. This amp's a lot more growly than it was before. mid works really well on this amp now. It's got a real good sweep. So that's all the mid out. If we sweep it all the way in, it works brilliant, that does. See the bass on this speaker. You can hear it cut in, but it's just got no bottom end, this speaker. The Marshall Class 5 modded. I've really enjoyed doing this, and I like these amps. They're great. It's you know, so they've got lovely cabinets. Speaker, yeah, it's not great, but then again, most people upgrade speakers in amps, pretty normal. So you don't always get the speaker you like. Some people may love that. We know how much, you know, speakers change the sound of an amp. Sounds really good on the 4x12. Works a lot better now, but yeah, good bones. So that'll do it for this one. Thanks for watching, and you all take care, and I shall see you soon in another video. Bye bye for now.